What if everything you thought you knew about the universe was just part of the story? Imagine an invisible force making up 85% of all the matter in the cosmos, silently pulling the strings, dictating how entire galaxies are born, how they live, and how they die. This is not a myth. This is the reality of our universe. This is the story of the ghost in the machine, the unseen architect behind the universe's most breathtaking structures. This is dark matter. For centuries, we have looked up at the night sky and seen galaxies as grand cities of stars, majestic islands of light held together by their own gravity. But that was a profound misunderstanding. The visible matter, the stars, the gas, the dust, everything we can see, is just the luminous foam on a deep, dark, invisible ocean. Without this mysterious, unseen ingredient, galaxies as we know them simply would not exist. From the smallest, faintest dwarf galaxies to the most sprawling, majestic spirals like our own Milky Way, dark matter's immense gravitational pull is the unseen hand that sculpted them all. It is the silent puppet master of the cosmos. Before there was light, there was the plan. Before the first star ever ignited, dark matter was already laying the groundwork for the universe we see today. In the aftermath of the Big Bang, as the universe expanded and cooled, this strange, invisible substance began to clump together under its own immense gravity. It formed massive, spherical structures known as halos. These halos were the invisible skeletons of the cosmos. They were the gravitational blueprints for everything that was to come. These immense halos of dark matter acted as gravitational wells, cosmic valleys in the fabric of space-time. They began to powerfully draw in the ordinary matter of the universe, the clouds of hydrogen and helium gas that were drifting aimlessly in the void. Think of them as the invisible scaffolding around which the entire visible universe was built. The grand filaments of the cosmic web, the superclusters, the galaxies, and even the stars, all formed within these pre-existing structures of pure darkness. It is a truly mind-bending concept. The shining, brilliant universe we see is just the decoration on an invisible architecture that was in place billions of years before. The greatest discoveries are made not in the light, but in the dark. We are on a quest to map the unseen universe, to find the phantoms that have been hiding from us since the dawn of time. To be a part of this hunt, to witness the unveiling of the cosmic shadows, subscribe to CosmoQuest 888 and activate the notification bell. You will not want to be left in the dark. The existence of this cosmic scaffolding is the key to understanding the speed of creation. Without the powerful, pre-existing gravity of dark matter halos, the ordinary gas of the early universe would have been too diffuse. The gentle pull of its own gravity would have been too weak to overcome the universe's expansion. Stars would have struggled to coalesce. The formation of dense, massive structures like galaxies would have taken far, far longer, if it happened at all. Dark matter was the accelerator. It was like gravity on steroids. Its immense pull gathered the raw materials of creation quickly and efficiently, allowing the first galaxies, the first galaxy clusters, and the great superclusters to form rapidly, shaping the large-scale, web-like structure of the cosmos we observe today. It is the secret ingredient in the cosmic recipe, the catalyst that kick-started the universe's most dramatic and beautiful formations. But how can we be so sure of something we cannot see, touch, or detect in any direct way? The answer is that the universe itself is shouting about dark matter's existence. We just needed to learn how to listen to its gravitational whispers. The first clue was in the way galaxies rotate. When we look at a spiral galaxy, we expect the stars at the outer edge to move much more slowly than the stars near the center, just as the outer planets in our solar system move slower than the inner ones. But that is not what we see. The stars on the edge of galaxies are moving impossibly fast, so fast that the galaxy's visible gravity should not be able to hold on to them. They should be flung off into the void. The only way they can maintain their orbits is if the galaxy is embedded in a massive, invisible halo of matter that is holding them in its gravitational grip. This was the first smoking gun for dark matter. Then came the evidence from gravitational lensing. Einstein's theory of relativity tells us that massive objects bend the fabric of space-time, causing the light from distant objects to be distorted and magnified. Astronomers now regularly see this effect. We see the light from distant galaxies being warped into beautiful arcs and rings as it passes by a closer galaxy cluster. But when we calculate the mass of all the visible matter in the cluster, it is not nearly enough to create the lensing effect we observe. There has to be something else there, an enormous amount of invisible mass bending the light. That something is dark matter. From the subtle temperature fluctuations in the cosmic microwave background, the baby picture of our universe, to the way galaxy clusters collide and leave their dark matter behind, the evidence is overwhelming. The universe is telling us a secret. It is telling us that what we see is only a tiny fraction of what is truly there. As our universe continues its long journey into the future, dark matter will remain the dominant force, the silent king. Its invisible halos will continue to guide the slow cosmic dance of galaxies, dictating future collisions and mergers. Understanding the true nature of dark matter is therefore the key to unlocking the ultimate fate of our universe. Is it a substance that will remain stable forever, allowing the universe to expand into a cold, dark freeze? Or could it decay, releasing energy and potentially leading to a different, more dramatic end? The quest to finally directly detect a dark matter particle is one of the most exciting and well-funded frontiers in all of science. Deep underground, in heavily shielded laboratories, scientists are waiting for a single, ghostly particle to bump into their detectors. When that day comes, it will revolutionize our understanding of reality, confirming the existence of a shadow universe that has been hiding in plain sight all along. We are living in a universe built by a ghost, and the hunt to finally see it has only just begun.